Okay, everybody, this is chapter 7.4, similarity in right triangles. So we're specifically going with right triangles in this section, okay? This is kind of a cool section. Triangles are inherently one of the strongest kind of geometric figures when you're building things. And right triangles typically are going to be used the most often. Or triangles that are equilateral are going to be used a lot in building things, anywhere from bridges to homes to, the rafters in your homes, all kinds of stuff that if you want it to be really strong, a triangle is going to disperse weight and allow something to kind of get loaded up and it could bear all that weight and not fall apart, okay? So this is kind of a cool section. It can get kind of tricky. So very, very important that I stress you to go back and look at this, especially when we get to the end of this section. There's some stuff here that you really gotta have your vocab down, the different terms that we have, and then be able to identify certain things and where to put them. We're going to set up some proportions here too, and you really, really got to make sure you put things in the right place. Okay. So you got this theorem here, you got this one big right triangle, but if I draw an altitude, so an altitude is always drawn at a right angle to either from an angle to its opposite side or opposite side to the opposite angle. But we're going to go ahead in if you have this note packet, we're going to go ahead and identify this as being an altitude. So I can determine it's an altitude because it's at a right angle to a side of the triangle. Okay. So I hope that you understand that triangle ABC is a right triangle because you've got the right angle up here. So ABC is a right triangle, but when I draw that altitude in here, I now create two other right triangles. So really, technically, I've got three triangles in one, and they're all right triangles. And I said this early in another section that all right triangles are similar to each other. Okay. So from that, you can over here, you can write out these similarity statements. So they took the big triangle ABC and said it was equal, or I'm sorry, similar to in this case, the smaller right triangle. Okay, and then they stuck with the big right triangle and said it was similar then to the other right triangle that was created. Okay, and then what they did was they took these two guys and they said they were similar in this last similarity statement. Okay, so kind of a really cool rule. You can create this if you've got a right triangle. Let me draw it this way here. It's more of the profile that we see. So from that right angle, I can draw a line segment to the opposite side and draw it perpendicular to that side, and that creates a right angle. Well, now I've got three right triangles, and they're all similar to each other. Okay, so that's kind of, and this is an altitude. All right, so an altitude is drawn at a right angle to the opposite side. Typically, they're going to draw it in this direction, okay, from the angle to the opposite side. Okay, so have that one down. So another one that you got to come back at and you got to look at and know because it gets used a lot. All right, so now we're going to take a look at this. What similarity statement can you write relating the three triangles on the diagram? So this angle right here at angle P is really showing you the bigger right triangle. Okay, so P and Q and R. But what it did was it now, when I drew an altitude, okay, now what it did was it created another right angle, SQP. Okay. And then it created a third one over here. So SPR. Okay. So by that theorem we just had, we can say that all three of them were similar. Okay, so I think what they did last time was they took the big one. So the big one was triangle PQR is similar to triangle. Then we'll go to the one that was on the left, and you got to make sure that your letters kind of match up. So we started with the right angle at P, so the right angle here is at S, and they went PQ, so we're going to go opposite that. So we'll go PQ again, so PQS. All right. They stuck with the bigger one for a second time. Okay, so PQR similar to triangle, and let's make sure we go the right way here too. So PQR. This one we have to go SPR. Okay. I think I did that one right. Just trying to be as correct as possible. All right, and then the last step. And so you're always going to get three because you got three triangles. I can say the two smaller ones are going to be similar to each other. So we'll go SQP, starting at the right angle, is similar to triangle SQ, so SPR. I think that's right. I would mark you wrong if you didn't have the letters exactly in the same order. Okay, so we want to make sure that we got that theorem down, and write a similarity statement. It's going to take all three of these to be able to write a similarity statement. Okay, let's write that down so we don't forget. Okay, go back and study that one. Okay. All right. So that's where we're going to have to get really good with our math and really good with our vocab and really good with identification. There's this thing called geometric mean. It's a math algebraic really expression, even though it's got the word geometry in it. If you remember back in Algebra 1, mean really means average. In geometric mean, it's kind of doing the same thing, except that I've got a common, and so if you'll notice they've written this proportion out. You've got a common variable or value that you're going to have that will be diagonally from each other. So this one's kind of important the way you set it up. And I'm actually going to show you a shortcut too. Okay. So I would do my cross products first. Okay. And then when I do that, I'm going to do it both ways. So x times x, you got to be careful here. X times x is x squared. So you got to remember that. That kind of helps us with our explanation here. And a times b is just ab. Okay. Now, really what I'm trying to do is just solve for x. So how do I solve for x here? Well, to get x all by itself, I would take the square root of both sides. And because, you know, a, b are not really numbers or values, it's just going to be the square root of whatever a times b is. Okay? So if it was some number, I could stick it in my calculator and get an actual number. All right? So that's kind of the book way to explain what geometric mean is. You would do your set proportion, have a value that's the same diagonally from each other, and then, you know, do your multiplication. Okay. But what I would do, I don't want to set all that stuff up and do all this work. Okay. So if you really understood what I did here, you want to multiply the two numbers. So you're always going to get two numbers. Multiply the two numbers and take the square root of the answer. Okay, so that's for geometric mean. So I think it's just a simpler way. So in this case, they gave me two numbers. Take the two numbers, multiply them together. I get this, then take the square root of it. Okay, and 72 is not a perfect square, so if you went and put this, you know, into your calculator, the square of 72 is somewhere between 8 and 9. 8 times 8 is 64. 9 times 9 is 81. I think it's closer to 64, but not by much. So I'm going to guess it's 8.4. If you guys want to put that in your calculator, you can tell me if I'm wrong or not. Okay. So that's the 8.4 is the geometric mean of those two numbers. Okay. And we have to do that for what we're going to. So we want to make sure that, you know, we kind of know what we're doing here. Okay. Okay. Here we go. So one, this is kind of cool stuff. It's kind of calculus and geometry, and I don't want to scare you off here. It's more you knowing vocab that's being introduced here, and some of you already been introduced to, so you should know it. And then being able to set up a proportion. Okay. So and you got to identify here what you've got and where it is in these triangles. So we're going back to these three triangles. You've got a big triangle, but we've drawn in an altitude, and we've now taken that one right triangle and drawn it into three right triangles. Okay. So you got to know some of these. These are some corollaries here that we have of right triangles. So let me just read it. The length of the altitude to the hypotenuse of a right triangle. So here's, I got my big right triangle. Here's the altitude being drawn to the hypotenuse. You might want to label that. Is the geometric mean of the lengths of the segments of the hypotenuse. Okay. So you got they gave you the geometric mean of the altitude. They gave you a length of 4. It's the geometric mean of the two segments of the hypotenuse. Okay. So when we drew this altitude in, we created two separate segments made up of the hypotenuse. So that altitude is the geometric mean. So that's the 4. Remember, we had x's in the same spot in our little example earlier. Well, now they gave us a geometric mean. It's 4. And then we took the two sides, or the two segments of the hypotenuse, and put them opposite each other. Okay. So let me get rid of this mess. And in this case, we don't have a variable. They actually gave us measurements, but they're using it to prove this this corollary. So 4 times 4 is 16, and 2 times 8 is 16. Okay. So it proves that the math that we were supposed to have done would have come out to make it equal. Okay. So that's one, where you've got an altitude and it's cutting the hypotenuse into two segments. Okay. So, and then we're going to have to play games here because they're not going to give us information, but we have to identify what we have and need. Okay. The second corollary, the altitude to the hypotenuse of a right triangle is separating the hypotenuse. So the length of each leg of the triangle is the geometric mean of the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to the leg, OMG. Okay. Well, first off, we got a hypotenuse. Okay. So the hypotenuse, this is my altitude. Let's label it so we know what things are. So when we go back, we know what we're looking at. Okay. Actually, let me get rid of it so I don't cover up this because we need that. Well, let me flip it over. Got to remember, the altitude is drawn from a right angle perpendicular to the opposite side, which is the hypotenuse. So here's your hypotenuse. Let's label that. Okay, it's really critical that we understand how this is getting cut up. And I'm not going to expect that you get this all right now. Okay, you have to go back and look at this. Okay, all right. Now another term that comes up, and we'll kind of underline this last one. You might want to do that too. the length of the segment of the hypotenuse adjacent to the leg. Now remember that I've got one side of a right triangle that's got a specific name, hypotenuse. The other two sides of the triangle are called legs, okay? What does adjacent mean? Adjacent means next to. So in this case, I'm looking for one that they give me. I need some information, so I'm looking for adjacent. I've got two legs. Okay, I got this leg and I got this leg, and I need one that's adjacent to the hypotenuse. Well, both those legs are adjacent to the hypotenuse, but they give me this one. So that's, I have choices here, but my choice is kind of forced on me by what they give me, okay? And that leg is the geometric mean, okay? So that 2 goes in separate proportion. That 2 goes into both places, okay? So both of these corollaries here have specifics about what the geometric mean is, okay? So you saw it up here, you saw it up here. That was the altitude, the 4. That was going here, okay? You got the geometric mean here. The geometric mean was the adjacent next to the, or adjacent to the hypotenuse. That's, they gave it to me. So remember, geometric mean is like a repetition of either the value, or maybe later on you'll see it'll be a variable, okay? So then, get rid of this again. I'm going to take the segments of the hypotenuse. Now, this one's a little bit different. They want you to take the whole hypotenuse here. So it's a really good thing to go back and look at this. And in the segment adjacent to the segment of the hypotenuse adjacent to the leg. So that was that 1. So these two have kind of a relationship here. Okay, so this one's kind of tough. And you're only going to know it by looking at this when you're doing it. So make sure you have your notes out when you're doing these problems. So just to prove it, 2 times 2 is 4. And 4 times 1 is also 4. So if they come out equal, that means we set it up correctly. Okay? All right. That's tough. And the only way you get good at that is by looking at it and going back over it. Okay? There's no shortcut on this stuff right here. Okay? And this is some engineering that we're doing right now. Okay? I got to use some stuff when I'm building whatever. It's not a cookie cutter. Sometimes things are different shapes and sizes, and I got to do some figuring here. Okay? All right. So let's go here and try this really quick. I'm just going to do these for you. And what I'm going to do is I'm going to do the first corollary dealing with the altitude and what they gave me. Okay, so I got the big right triangle. It's this guy right here. Okay, here's my right angle for it. So I've drawn an altitude. Now remember, in that first corollary, the altitude they gave me was 4. Then the altitude was my geometric mean. Okay. So what I want to do is I'm going to set up 2 fractions, and I'm going to put the altitude in for my geometric mean. I'm going to repeat it. That's what geometric means. I'm using my own explanation. It's kind of making me use it repetitiously. Okay. Now it's equal to, or what I'm going to use is the 2 pieces of the hypotenuse. Now remember, this is the hypotenuse of that right triangle. So the 2 pieces were 4 and 5. Okay. All right. So what I'm going to do then is go ahead and I can cheat here. I can do my cross products. I'm going to get y squared equals 20. Okay. And then I would take the square root of both sides. Okay. Now what I did, because I've done it so often, I cheated. I just know that to get a geometric mean, I would multiply those 2 and take its square root. And so when I do that, we did some funky stuff here. Let me do this really fast. We did a simplified radical on that. I don't want you to do that. So we're going to go second function, square root, put in 20, and we're going to get a decimal answer. I'm going to round it to the nearest tenth, and it rounds to that, 4.5. So that's the length of the altitude, which is important. If you're building rafters in your house, you need altitudes to hold that stuff together. And depending on how tall your roof is and where your ceiling's at, that altitude can change, and that's where you would typically use that. Okay. All right. So I think that for me, the second one's a little tougher because I got to remember what I'm supposed to use. My geometric mean in the second one is the adjacent leg to the hypotenuse. Okay. That's my geometric mean. Now, here's your hypotenuse, and I got this leg's adjacent, and this leg's adjacent, but they don't give me anything on the right-hand side. They do give me this guy. So that's my adjacent leg. So that's my geometric mean. So I'm going to repetition it. Okay, so put it opposite itself in a proportion. And now you got to go back and really remember what they told us in this, and they told us a lot in this. So I typically look at these and what the picture is, okay? So I know I got a mess going on there, but I'm going to use the leg that's adjacent to it. So the leg that's adjacent to the segment, the segment of the hypotenuse next to it is 4, okay? And if you went back and look at this, and I'll try to clean this back up, the example. So I used remember that I think I used the word relationship. These two have a relationship, okay? So they're adjacent to each other. This is a piece of the hypotenuse. This is my geometric mean. But then they use the entire hypotenuse in my other piece of the proportion. So in this case, that's going to be 9, okay? So once again, you can use your cross products, but remember, I'm going to cheat. I don't need to go x times x is x squared and 4 times 9 is 36. Okay, I don't have to do that. I'm just going to go 4 times 9 is 36. Take the square root of that, and I get 6. Okay. All right. Okay, so that's kind of how you do those. Just really important, and you have to go back and read that. There's no way that someone's going to just get that down cold, just watching me or listening to me doing it. You got to go back and look at it. You got to look at all the vocab. You got to look at the words, and then you got to be able to do it. Okay. On this one down here, I think this one is more important for me to kind of do this with you in person because there's some algebra and math that we have to use in this, and I got to be able to explain it. So it gets a little tough for a lot of people to be able to do that, and you got to there's not a lot of information here, so you got to be smart and go get some more information. So on this one, what I like to do is probably do it with you in person. And you can write it down or take notes with it in person. This takes us about 10 minutes to do by ourselves. So if I happen to see you, just say, hey, can we do this last problem together really quick? And we could do it really fast, like during lunch or after school, before school, whatever. It gets a little dicey. Okay. So that'll be it for section 4. Make sure, really study. Go back over that stuff. Know what things are. Know what the vocab is. And please, if you're really stuck, just come and see me. We'll figure it out together, okay? And please, the homework assignments too, if you've got questions on the homework, ask me about those.